Hello students, Miss Slyman here in the first video to talk about limits. So the idea of a limit is that we're looking at a function or relation of some sort, and we want to look at a particular x value and determine what the y value should be. Sometimes the y value actually will exist and be the limit, but other times a limit is more like a guess, and if we close our eyes and got really close to that point, what would we think the y value should be? So we look at x really close to some value, but not actually equal to that value. And if the y value is approaching a constant value L from either direction as we get closer and closer to A, then we say that it has a limit of whatever that value L was, and we write our limit notation this way. So we say that x is going to A, but we don't actually have to reach A, and the function doesn't have to exist at A. So let's look at this in the form of this example. So we want to determine the limit as x approaches 4 of f of x for the function f of x equals this rational. So using your graphing calculator, we're going to graph it. Well, first of all, as soon as I see this rational, I think that my domain is all reals except 4. So in this function, my domain, so let's be reminded about what domain is. I'm going to switch that to blue. Okay, so our domain is going to be x is an element of reals where x is not equal to 4, because if x is 4, then we divide by 0. Which makes mathematicians upset. So we're not going to divide by 0. So I'm going to go over to my calculator, and I'm going to graph this function. So I'm going to make a new document. I'm going to make a graph. I'm going to type in my function. So it's nice that I'm on my computer and can type it in. So minus 9x plus 20. Wow, I hope that fan noise from the computer is not coming through for you. Divide by x minus 4. Make sure you use your parentheses so that your function graphs the way you want it. And it looks like it's a straight line. So it looks like I have an x-intercept of 5. It looks like I have a y-intercept, 3, 4, also a 5. So it looks like I have a slope of 1. So I'm going to come in and sketch that graph. So 1, 2, 3, 4, 5 here. Slope of 1, it looks something like this. The thing is, though, that I know when x is 4, over here, I know my function doesn't exist. So I have to draw a hole here to show that I have a point of discontinuity. So my consideration from step 2, that when x equals 4, the function doesn't exist, I'm going to draw in a hole. Actually, I'm going to draw a circle to represent the hole. So the point of discontinuity is a point that's excluded from the domain. And it's a point where the function does not exist. So I'm going to use DNE for does not exist. So we've already said it's a straight line. My slope was 1. So I'm going to say that the equation appears to be 1 equals x plus 5. Slope of 1. Ooh, how about we go with x minus 5? All right. Looking at this, my point of discontinuity appears to be the point 4, negative 1. Let's see if we can verify that. So we want to create a table of values. I can do that super easy. I've already got my graph. So I'm going to look in my menu and see that I've got my table option down here. And I could split screen to see my table. All right, so I could look at x values. I can also, hopefully, put in specific x values. So looking at my table here, I wanted to see 4.5, 4.2, etc., etc. So let's see, can I replace that? No. X equals. Okay, someone's gonna have to teach me how to do this because I need help with my table. Let's see, table. Choose. No, that didn't seem to help. Table. Edit table settings. Aha. So I don't want my independent to be auto. I want it to ask me. And now, all right. So now I can put in my 4.5. Let's try that again. 4.5, 4.2, 4.1, 4.01, 4.001. And it looks like all of those values are getting closer and closer to -1. Well, let's look at the other side. Let's go 3.5, 3.8, 3.9, 3.99, 3.999. And again, we're getting closer and closer to -1. So that's what it appeared to look like on this graph. And it's what it's looking like at the table. So as I'm approaching from the left-hand side, so looking at my coming from 3 towards 4, these values are all less than -1, and that makes sense because they're down here. When I looked up at my values coming from the right-hand side, so at 4.5, I was at 1/2, and then all of my values are greater than -1. That also makes sense. So we created that, and then we can fill in our notes. So since the values of f of x are getting closer to -1 as x gets closer to 4 from the right, we write the limit as x approaches 4 from the right. I put this plus sign in as an exponent. So notice this is like the notation up here, except now with that a value, so my a value is 4, but I also put a plus to denote that I was coming from the right. I was coming from the positive side of the x-axis. So that limit was -1. On the other side, when I'm approaching from the negative side, I could also say it's -1. And since the right-hand limit equals the left-hand limit, I say the limit exists and the limit is 4. We thought earlier that the equation of this line was y equals x minus 5. Well, if I simplify my function, then I can factor the top, numerator and denominator cancel, and I'm left with what appears to be x minus 5. So then when x goes to 4, well, now I can just substitute in the 4 because I'm not dividing by 0 anymore. And in fact, 4 minus 5 does equal -1.